Week 7 is all about loops, where a loop is a group of code that allows a program to repeatedly execute a group of code. So over here we have our flow sheet. We enter the code in up here, and then we hit some sort of conditional expression. So it's kind of like an if statement or kind of like a switch statement. So if that condition is true, it's going to go back up. It's going to execute the code inside of here and then go back and check that statement again. If it's true, it's going to repeat the code and go back up. If it's true, it's going to repeat the code and go back up. And it's going to keep doing that over and over and over again until this conditional expression is false, and then it will exit. So that's what a loop is. It's a special kind of branching statement. Each time we go through the loop, each time we do this, it's called an iteration or a pass, but you'll hear the word iteration a lot. And we can go through that code 1 time, 0 times, 10 times, an infinite number of times. We can go through code as many times as possible, as long as this condition is true. Sometimes we have infinite times as well, so it never stops, which if you do ever run into an infinite loop and you want to stop it, you can press Control-C. It is Control-C on both Mac and Windows. It's not Command on a Mac, it's Control. Okay, so let's look at an example of when we might want to do this. If you remember homework 2, we had to calculate all of these variables. And oh my goodness, you copied and pasted and copied and pasted and copied and pasted and copied and pasted. And I think my solution is about 57 lines of code, depending on how much. But what we can do is we can write it in a loop. We can repeat something for however many times we want. So for example, here I have an initial set of values for VLD, epsilon, and nu. And so I put those here. And then I said, okay, here's my first calculation. Here's my second calculation. I'm going to print out my case, and then I'm going to update my variables. So update these variables, and then I'm going to go back and do this again. So note, this is a loop. I'm repeating for a certain number of times. This is called a for loop, and it repeats while the numbers exist here in this array. Okay, so if I run this code, change folder, I can see that I've done this for 4 different times, where case 1 is with this first set of values. Case 2 is with my updated set of values. Case 3 is with my next updated set of values. Case 4 is with my last updated set of values. But I've repeated this code inside of this loop 4 different times, which means I have less copying and pasting, and I have much shorter code that I can work with. So there are 2 different kinds of loops that we are going to use. And there's 2 different kinds of loops you can have in MATLAB. A while loop. A while loop is our generic loop statement. It's kind of like an if statement, very similar to if, where I have if conditional. Same thing. I'm going to have while conditional. And they behave very similar. The only difference is this if is checked once, and this while is checked for as many times as it needs to be. But it repeats a group of code until a condition is met. And the condition expression evaluates to false. So it's our generic while, it's our generic type of loop. The name of the variable that controls whether or not this is true is called a loop control variable. And that variable is going to be initialized before my loop. So int k equals 2. It's going to be tested in my conditional expression. So while k is less than 10, and then modified in the code block. So k equals k plus 1. So this is my generic while loop. Initialized before, tested in the conditional, modified in the code block. So I have this loop control variable that I go through and I check this. Okay, yep, I've reached this. Is k less than 10? True. Execute the code inside. Execute the code inside. And then go back up and check it again. Is k still less than 10? If it is, execute the code inside. Go back up, check it again, and keep going over and over and over again. Okay? So it's really important that I have all these 3 pieces. And this is our generic syntax. So variable is initialized before the loop. Then I have it's tested in the conditional expression next to the word while. And then I have variable incremented. And then I have end. Every while has an end, just like every for is going to have an end. Every if has an end. Every switch has an end. Every function has an end. Just some warnings about writing while loops. A lot of errors can happen in that initialization, modification, and testing. So it's super important that our loop control variable is initialized appropriately before we enter in the loop. If it's not initialized appropriately, then we might execute our loop 0 times when we want to execute it more than 0 times. We also need to make sure we are testing our control variable correctly, because if we don't, we could execute our code 0 times, an infinite number of times. We can make lots of mistakes with our testing, with our conditional expression that we create. And then lastly, it's important that our loop control variable is modified inside the body of the loop, because if it's not, then we typically can have an infinite loop, because the variable never changes. So while writing while loops, there's some questions we can ask ourselves in order to guide the process. So first, determine the purpose of the loop. I like to literally do this by start writing code. Start writing code. Literally, what in the world are you trying to repeat? What code needs to be repeated? Start by writing something. Copy and paste, change values, determine a pattern. Then once you have that pattern, once you know what needs to be repeated, what the purpose of the loop is, then you need to go ahead and determine those 3 pieces. Figure out what your initialization is supposed to be. The pattern that repeats, what does it start at? That's your initialization. Then figure out when your loop should stop. So when are you going to stop repeating, copying, and pasting? How many times do you need to do that? Or what determines whether or not you're going to continue doing that? Okay, figure out when it should stop. That's the easier one to figure out. And then we need to invert it in order to figure out when we want to continue. Okay, so that's what we put next to while. While our continuation, that goes right here. Okay, so figure out when we want to stop, and then invert it to figure out when we want to continue. And then lastly, take this code here, write our loop body, and make sure you update your variables. So what is the pattern that you determined? What is that first value, and how does that pattern update? Okay, so make sure you update your variable inside of your loop body. That's a while loop. That is our generic kind of loop. MATLAB also has a for loop, which is a specific kind of loop that iterates through a predetermined number of values. So if we know exactly what that pattern is, what those values are, then we can use a for loop, where we say for I equals, and then we give it an array of values where I is going to be one of those values, one piece at a time. So if I go back and look at that code we talked about, here it is, for I equals 1 through 4. So these are numbers 1, 2, 3, 4, where I is just going to be 1, then 2, then 3, then 4. Okay, so that variable, this I here, it's not a loop control variable anymore. It's a loop index variable. It's just a name, just vocabulary. We typically name it I, J, K, M, or N. It follows general variable names and should be descriptive, but I, J, K, M, and N tend to be common ones that are used. It is a scalar, which is confusing to students because students think, oh, it's an array. It says for I equals these values. It's a scalar. It's these numbers one at a time. So essentially it's going to repeat while there's another number for it to change to. Okay, so it changes values during each pass or every iteration according to the next given value in the array. And then the for loop will continue to repeat the code until it runs out of values. So here's our syntax for index I, for index is typically called, equals values to iterate through. So the first value, then it's the second value, then it's the third value, then the fourth and the fifth and the sixth until it runs out of values. So common misconception is a scalar, not an array. Okay, so those are our 2 kinds of loops, a while loop and a for loop. They are not interchangeable. Okay, that's important to note. They are not interchangeable. So when do we use a while loop and when do we use a for loop? Use a while loop when you need to repeat code for an undetermined number of times. When you have a pattern, but you don't know when that pattern stops, or that pattern stops based on a condition. Use a for loop when you need to repeat code a predetermined number of times. Okay, so when you know exactly which values that variable needs to be. Is it going to be 1, 2, 3, 4? Is it going to be 6, 9, 12, and 15? So what variables do you need it to be? In general, loops are super useful. MATLAB isn't quite optimized for loops, so it's important that we use loops only when we need to in MATLAB. And the more you use them, and the more you use element by element operations and all that other stuff that happens in MATLAB, you'll get used to figuring out, hopefully, when to use one over the other. But in general, we should really only use loops in MATLAB when we absolutely need to. Okay, last thing to note, any valid code can go inside of a loop, including another looping statement. This is known as a nested structure. You'll see them. We can put if statements inside of a loop. We can put loops inside of a loop. We can put loops inside of if statements. It's all nesting structures, and this is where we need to be sure that we have our indentation. So note, I can clearly see this code corresponds to my outer for, and this code corresponds to my inner for. So that's where our indentation matters. And in MATLAB, they have the indentation button up in the top ribbon, or you can do Control+I in order to automatically indent. Okay. We generally, depending on the application, one loop is typically good enough in MATLAB for all of our applications, but sometimes we use 2 loops, specifically when we are iterating through an array. So 1 loop we generally use to iterate through a vector, and then 2 loops to iterate through a matrix. And we'll look at examples of that. Okay, that's pretty much our content. Writing loops tends to be very challenging. So it's important that we understand how to debug our loops, how to make sure our loops are doing the things they are supposed to be doing. Because it's not quite top to bottom anymore. It's not just this and then maybe jump over some code and keep going anymore. Now it's this and then a bunch of this and then go. So we've got to understand what is happening when we have that loop, when we have that code repeating over and over and over again. So one of the ways to debug code is to use print statements to print out values of importance within each iteration of the loop. So I have some code here, and you can see I have these print statements that show up. I have 2 print statements. And the goal of this code is to find the maximum value in every column of this array. So here I have array A equals 10, 1, 7, 4, 3, 6, 6, 9, 2. And I'm trying to find the maximum value in each column. So I want the 10, the 9, and the 7 to be my maximum value. However, it's not working the way I want it to work. So I need to go ahead and go through and try to figure out what the heck is happening. Okay, so here I have nested for loops, which is fine. I can see this indentation where this code is for my outer for loop. So this code is repeated for these values. And then this code is repeated for these values. Yeah, so I can see my code inside of my code. But I've got my nice indentation there to indicate which code is associated with which loop. And I also have an if statement. So notice I have double nested statements, and this is totally normal. Okay, so some of the things you can see I have printed out. I have C and R printed out. C and R are my loop index variables. So those are common things to print out, and I can see how they're changing. Other things I have printed out. ARC. ARC is whichever value inside of the array that I'm indexing. So I can see ARC, that's indexing. I want to access the array A, which part of the array? The part that corresponds to the number R and the number C. And then I'm also printing out the maximum C. So I'm printing out whatever I'm trying to store. So I'm trying to create a vector that stores all my maximum values. So it should say 10, 9, and 7. So I'm printing out whichever maximum I'm currently finding. And then lastly, I'm printing out my maximum after my conditional. Okay, so here you can see what's printed out. So for every time I go through the loop, I print out the value of C, the value of R. I print out the maximum value. That's currently my maximum value before my branching statement. I print out my conditional in my branching statement. I'm printing out this statement here to see if it's make sure it's doing what it's supposed to be doing. And then I'm printing out my maximum here after my branching statement. And I can see looking at these print statements that I've got a couple things that show up. First of all, I can see right here and right here and right here, I have some unnecessary comparisons. So I don't need to compare if 10 is less than 10. I don't need to compare if 1 is less than 1. I don't need to compare if 7 is less than 7. Okay, that's not necessarily determining whether my loop is wrong. It's just saying, hey, I've discovered some inefficiencies in my code. Other things I'm determining is here, I'm having the wrong comparison. When I compare 4 with 10, which is this number here with this number here, it's giving me the wrong comparison. It's saying my maximum is the smaller of the two. So I've got a wrong comparison there. I can see it shows up here in my next column, and I can see it shows up here in my next column. So I can see that there's something wrong, and I've got this arrow. I need to change that. So I can begin to see, okay, what's wrong with my code? And then lastly, the last thing to point out is here's my answer for column 1, my answer for column 2, and my answer for column 3. And I can see it's not finding the maximum, it's finding the minimum value. So printing out statements can really help us figure out what's going on in our code, what's going on in our loops, so we can begin to see maybe what's wrong with it, and I can begin to figure out how to correct my code. Okay, common things to print out would be loop controller index variables, so loop control variable in a while loop, index variables in a for loop, results of conditional statements. If I have a branching statement, so if I have a while has conditional statements, if I have an if that has a conditional statement, values before and after calculations. So you can see here I printed out the maximum value before my if statement and after my if statement. And then honestly, any variable that changes values. So remember, when we have a loop, we have things that change inside of the loop, especially in a while loop, so we can begin to see how things are changing as we execute our loop. Okay, the last two things to mention for this is we have two keywords, a break keyword and a continue keyword. Break and continue allow us to either stop our loop early or skip over some code in our loop. So the break function or the break command, the break statement, executes, terminates. So it stops my loop early. Stops loop early. So it's generally wrapped in an if statement where if I've reached this condition, then I want to go ahead and stop. It's going to immediately jump out and it's going to ignore anything that's left in my comparison, in my for loop. It's going to stop early. Continue is very similar, except it's going to go ahead and stop and go back up to the top again, go to my next iteration. So if there's code down here, this is ignored. In general, we can write loops without a break statement and without a continue statement. They really should only be used when it results in clearer to understand code. But they are possible. We can break a code early, or we can skip any code below and just continue to the next iteration. Okay, but both of those commands are written inside branching statements. When they appear in nested loops, they will always refer to the code block that's in, so make sure you pay attention to the indentation. And then, like I said, most times we can design our code without break or continue. It should really only be used when it's easier to comprehend and easier to understand. Okay, which we will go over some examples of that as well. Okay, so that is loops. There's not a lot of content, but loops do tend to be challenging for students. So we will go over lots of examples, but the concept is not challenging in theory, but now the way we design our code can get a lot more complicated.